Okay, so the next numerical test, 8C, class 9, chapter 8, motion, these questions, okay? Let us first do those question 2, 3 on page 110 first. So let us write this one, question number 2, textbook, page 110. Go there. And let me read the question for us. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. So let us write that. Since we read the first sentence of the question saying a bus decreases its speed from higher speed 80 km per hour to 60 km per hour. All these things happen in a time of 5 seconds. Question is saying that. So this is a picture of a bus slowing down from high 80 to slow by applying brakes. So here, by reading this statement, we find initial velocity u is 80 km per hour. But we need to change this one to SI unit. And SI unit of, as we have been saying, SI unit follows the MKS system. So for length, it follows the meter. For mass, it follows kg. And for time, it follows second. So SI unit of distance is meter, mass kg, and time second. So it has to be in meter per second. So we need to change this to kilometer to or per hour to meter per second. So in order to do that, you move from here 1 to 3. So you're changing bigger to smaller unit. So we have to multiply 1, 2, 3, 0. Then kilometer will disappear and meter will come in. Then divided by here, no number means 1 is there, 1 hour. Hour needs to change to second. So 1, 2. So one movement there I count 60. Double movement means 1 more 60. Then this will become second meter per second. Right? So these two cancel here. 1, 2 zeros. 2 3s are 6. 2 4s are 8. 0, 0. 2 3s are 6. Here 2 2s are 4. 0, 0. 200 by 9, 3 3s are 9. Meter per second is the initial velocity of this bus. Right? So similarly, we can just do the final velocity v. Second one is the final. Always the first one that appears is the initial velocity, and finally the bus is slowing down. The final picture is the final velocity. So this is 60 and 1, 2, 3 to change this kilometer, and 1 hour multiplied by 60 into 60, just like we did here. Wrote similarly and went directly, okay? So that will become meter per second. So everything is now in SI unit. So 1, 2, 0, 6, 0, the 6, then 100, then 2, 3. So 50 by 3, okay? So that will be equal to here 50 by 3 meter per second. This is the final velocity. And this all happens in a period of time equal to 5 seconds is the time in which this change in velocity happens after the bus applies the brake slowly maybe. So with this u, v and t, we have to find, question is saying, go to the last statement, find the acceleration of the bus. So a equal to question mark is the acceleration of the bus. So here u, v and t are there, so we can easily use this equation to the famous equation for motion. So since v is equal to u plus at, we can manipulate this and write a equal to is v, then plus u go that side, minus u. T shifted means into will go down denominator. We've done this before, so we're just shortening the steps, okay? So here, very important, put your equal and put a long line first, because you're going to have fractions on the numerator. V here is, as you can see, 50 by 3 minus u here is, as you can see, 200 by 9. We have to use the SI unit. So here meter per second. Both of them have the common same unit, so we can take it out of the bracket as a common factor. So here time is here 5 seconds. Now write again equal, put a long line first, and let us deal with the upper part of the long line, the fraction there. 3 and 9 denominator LCM is 9. Then 3, how much is 9? That's right, 3 3s are 9. So 3 that multiplied to 50 is 150 minus 9 ones are 9. So that 1 will multiply the numerator 200, becomes 200, and bracket meter per second. Down here is a 5 second. Okay, so we can continue. Bring this one here, and if you continue, you're going to get here equal to long line 150 minus 200. The bigger number is the minus, so this will come out after subtraction 50 divided by 9. I mean to say minus 200 up plus 150 down, because we always put the higher absolute value up when we're subtracting. So when minus and plus we subtract, so here 0, then minus 5, upper sign minus. That's why we're getting minus 50 by 9 by here meter per second, and here 5 seconds. So finally minus 50 by 9 meter per second. We can write as this part. This long line means divided by. So when change to multiplication, we know this is by 1, so that down 1 will go up, numerator 5 seconds will come down. So we get that. So here 5 ones are 5, 5 tens are 50. So we're going to get here minus 10 by 9 meter per second, and this second go up, power is plus 1 if it's not given, right? The one shifted to the numerator will become second to the power minus 1. So that's how we do it, right? So now our final answer is here minus 10 by 9 meter per second square, minus 1, minus 1, minus 2, the unit of acceleration. So this can be your answer, or as you divide, you're going to get 9 ones are 9, 9 ones are 9, up to third place you can go, and then you can write your minus 1 point. And if third place of decimal, this is first, second, third, is less than 5, the second place will remain same. So this is your answer. So we can write here, which is negative, because it's clearly a minus number. Negative, right? So next, we can write here, once we're done with that, we can write here, therefore, acceleration is 0.11. Then in a final answer, you need not write minus if you don't want, okay? Not 0 point, but 1.11. We need not write because of this meter per second square in the direction opposite to the motion, in the direction opposite to the motion of the bus, because it's negative. That's why it's going to be in the opposite direction to the direction of the bus, or a motion of the bus, because from beginning we know it's going to come out minus, because 80 high speed to low speed means always acceleration is decreasing, right? So this is the picture of a object slowing down. Negative is always a picture of a negative acceleration, is always a picture of a moving object slowing down. Positive acceleration is always a picture of a object increasing its speed, okay, velocity. Now let's go to textbook question number 3. Question number 3, textbook, page on the same one, 110. Let me read the question for us. A train starting from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. Since the train starting, this word is going to be very important here, starting from the station, starting from the station attains okay, starting from a railway station, attains a speed of 40 km per hour. Attains speed means here only velocity, speed of 40 km per hour in 10 minutes. This is what the question is telling us. Here that means the word starting means it was not moving, it had to start moving. So initial velocity is 0 meter per second because we know it's starting. So this is your initial velocity of the train, and V is 40 km per hour, the second one. So here this will have to be changed into 000, 1, 2, 3, then meter, then here 1 into 60 into 60, then to second to the power minus 1. We have done enough number of times, so we're just going direct. Okay, now, so 0 and 0 cancels. 2 3s are 6, 2 2s are 4, 0 0, 2 3s are 6, 2 1s are 2, 0 0. So 100 by 9 meter per second is the final velocity of this train, right? All this happens in a time period of 10 minutes, which is equal to 10 minute to second. So multiplied by 160 and 600 second is the time. So moving from here, okay, I hope you're getting it. Moving from here, the question is saying, go back to question, find its acceleration. So A, question mark, is the acceleration of the train. So we have to, similar to the one we did just now. So since V equal to U plus AT, that is A equal to V minus U divided by T. We know that. So similar to the one we just did now. So we're going slightly faster. I hope that's okay. V here, 100 by 9, so we write that. Minus U here, 0, so you can just write that. And common unit is meter per second. Time is 600 seconds, as we can see here. Right? So we have got that one. So once we are through with that, we're going to get here. 100 minus 0 is simple case of 100. 100 by 9 minus 0. So meter per second. That means we can just neglect the minus and the 0. Now gone. Divided by 600 seconds. So 100 by 9 meter per second. We write this one as it is. Into, then this divided by, then down will up, 1 will go up, and numerator 600 will come down, second, along with the second. Then here 1, 2, 1, 2, 0 cancel. So 1 is divided by 9, 6 are 54, right? And here meter per second into second to the power plus 1, that one. If we bring to numerator, then this second will become second to the power minus 1 again. So our answer is therefore finally equal to not this time it's positive, so 1 divided by 54 meter minus 1 power we always add, so minus 2 meter per second square. So we can write here now if you want which is positive, or you can just stop here also, that is accepted, but just to get the meaning out of it, let's write down which is positive. Therefore acceleration is 1 by 54 meter per second square, comma, in the direction of motion, of the train. So that's how you can write your final answer if you want. Okay, so 2 and 3 done. So this is your final answer. Two and 3 done. Now we'll go to here 8.6, page 116, example 8.6 textbook. page 116. Let's go into do. Textbook, go to page 116. There, let me read the question. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. So here, since the car, according to the question, accelerates from, I think 18 km per hour to 36 km per hour. All this happens in 5 seconds. Look into your question and you'll find that, right? So let us write down the values from this statement. Therefore, first one that appears is initial velocity, 18 km per hour, which we need to convert to SI units or 000, because kilometer is changed to meter, means 1, 2, 3. Big unit to small unit, so multiply by, down here is 1, no number, means into 60, because we are changing the hour to 2 places move, so double 60. So here per second. So this is 0, 0. Then 6 3s are 18, 0. 6 5s are 30. So this is 5 meter per second. This is the initial velocity of the car. Okay. Well, similarly, we can just write in short now. V will be directly here. 36 means 36000 divided by 1 into 60 into 60 with the same explanation. This one, meter per second. 00 cancelled. 6 6 are 36. 0. 6 10s are 60. So this is 10 meter per second. Okay. So this is your final velocity. Okay. Please write it down carefully by thinking. Now u, v, and one more is their time. All these things, the velocity change from 5 meter per second to 10. This change happens in a time period of 5 seconds. That's fine. Already in the SI unit. So we're making sure everything is in our SI unit because we are using primarily the SI unit, unless the question otherwise ask. Okay. So now, number 1, go to question, and the question is asking you, calculate acceleration. So A is what they're asking you. Then number 2, distance covered by the car in that time. So that is the distance, means S. The distance covered by the car in 5 seconds, that means. And all these changes were happening. So let us start with 1. Now here u, v, and t are there. So we can use this famous equation again. So since v is equal to u plus at, that means we know a is equal to v minus u divided by t. We know this by now. Long line. V here is 10, okay, minus u is here 5, and the common SI unit is meter per second, and time is 5 seconds, as you can see here. So this one will be equal to 10 minus 5 by, down here 5 meter per second, and this can be shifted up, second to the power minus 1. So this is merely 1 meter per minus 1 minus 2 meter per second square. So this is the acceleration. So you can write here if you want, which is positive. The value of the acceleration is +1, so that's positive. Therefore, acceleration is 1 meter per second square, comma, in the direction of motion. You can stop there, or you can mention of the particular car that is mentioned in this question. So this is our first answer. Okay. Second one. Number 2, they are asking us to find the distance. Now since formula number 3 there on the right hand corner, S is equal to ut plus half at square. We could even use formula number 4. See, A is there, V, U is there. But we chose this because it's already arranged, okay? So, up to you. You can use the 4 also. Same answer you will get. So, next here, U is here, 5 meter per second, as you can see here, into second to the power minus 1 I brought down, so plus 1 now. Power is plus 1. T is 5 seconds. We did that, so we can cancel these two. Plus half into A just now here, 1 meter per second square. I'm just bringing this minus 2 power down, so it becomes square, plus half A T square, so 5 into 5. And T square means second into second square, so we can cancel this. Then here, we are going to get here 5 5s are 25 meter, this part. Then here 5 5s are 25 divided by 2 here meter. I think this is quite easy. Now here you can do like this also, or you can do either way also. So you can just do 25 meter divided by 2 is 12.5 meter. You can do like that also, or you can multiply here, do like the normal simplification also. So this is equal to 37.5 meter. So the distance, you can finally write down your answer if you want, or this can stop as your answer also. There, distance covered by the car. Distance covered in this case by the car is 37.5 meter. First answer here and second answer here. Okay, so one more question before we end this test portion. That is example 8.7 textbook, page 116. All these 4 numericals are a little bit similar. Okay, just do by thinking. It's quite easy, as you may be realizing by now. Okay, let me read the question for us. 8.7, page number 116. So there, the brakes to a car produces acceleration of 6 meters per second square in the opposite direction to the motion. I repeat that part. The brakes applied to car produces an acceleration of 6 meters per second square in the opposite direction of motion. So that means what? Since acceleration is acceleration of, according to question, 6 meters per second square is produced in the direction. Clearly question is saying direction opposite. Look down into your question, opposite, in the opposite direction, in the opposite direction. Same language you can use, opposite direction, in the opposite direction to the motion. So to the motion. So if acceleration is in the direction opposite to motion, we already now, because of this statement, we have to write A equal to minus 6 meters per second square. So it's a negative acceleration. We learned that already, right, in the previous numericals. So clearly textbook mention means we have to write minus. If they didn't mention, the means it's positive. Okay. So next, if the car takes 2 seconds to stop after the application of brakes. So again, car takes 2 seconds to stop. This is important. Here, this 2 seconds and stop is going to give us 2 values. Okay. What does it mean? That means time is 2 seconds. It takes 2 seconds for this thing to happen. And the word stop means final velocity is 0 meters per second. because finally stop. Initially it was moving, so this stop will mean the final velocity. Okay, so calculate the distance traveled during this time. So we have no information about the initial velocity. U is equal to question mark is the initial velocity. This one is the final velocity. So question is saying there, calculate the distance traveled during this time. So we have to write S question mark is the distance traveled that we don't know yet. So here we have to find S. T plus half at t square. Okay, so we have to use this formula most probably, ut plus half at t square. Our problem is we don't know u, so let us try to find out u. This question is slightly different from the first three, but it's quite okay. So how do you get u? V, T, A is there. See, V, T, A is there. So V, T, A is there means we can use this formula to find u. So right here, since the famous equation of motion is V is equal to u plus AT. So let us convert this to u. Don't move that. V don't move. Bring this one this side. Minus. Plus will become minus AT. So u, we can use this formula to find u. V is already here 0. So we write here 0 meter per second minus A is already minus 6. So you write here minus 6 meter per second square. By bringing down this second to the power minus 2, we can make it plus like that. Into, so here into time here. Time period is given 2 seconds. So you can write there 2 seconds into time. See. So what will happen here? You see? And you can put a bracket here just to differentiate. See here, this minus belongs to the formula here. This minus is from the value of A itself. Be careful with that. So this 0 can be neglected. Now minus the minus is plus. So this will be this second to the power 2 gone, right? Just to avoid confusion. So here 1 power gone. So 2 minus 1, 1 power left, which we do not write. So here minus and minus plus 6 meter, and this is finished. 6 2s are 12, sorry, 6 2s are 12 meter, and down here second means will go up per second. So you got the value of u now. Now if you have u is there, A, T, V is there. So you can use this formula here. S equal to ut, u is there, T is there, A is there, T is there. So we can find the distance which the question is asking. So you can just write down since S, the distance moved by this object before all these things happen, ut plus, every value is available now, so we can do now. U just now, that's why we were finding we needed u in this formula, so we first found out u. So u is 12 meter per second, bringing in this minus will become plus, into t is 2 seconds, plus half. Okay, we need more space, so let me just go here. So that will be equal to u is 12 meter per second into t is 2 seconds plus half into A here minus 6 meter per second square into t square means 2 into 2 second square, so up and down cancel, and up and down cancel. 12 2s are 24 meter. Then be careful with this here, see there's a minus, so 2 and 2 cancel, and minus into plus, minus into plus, so that will be plus, minus into minus, minus into plus, so minus. 6 2s are 12 meter, so that will be 12 minus 24 minus 12 is plus 12 meter. So this is the distance moved. So you can just write there, therefore, according to question text language, distance covered by the car, okay, distance covered by the car, okay, calculate the distance traveled during this time. So distance traveled by this car during this time is 12 meter. So that concludes your answers test portion 8C. Okay.